Alrighty, question 5. So it gives you the mass, it gives you pushed along a horizontal surface at 1.2. When it's let go, it travels 1.9 meters. We've got a initial velocity. We've got a u. There you go, initial velocity. We've got an s. We've got a distance. We know that it comes to rest, which must be our v. It wants us to calculate the acceleration, the deceleration. So v squared equals u squared plus 2as. We all know that. Rearrange to make a the subject first. There we go. V squared minus u squared divided by 2s. Just take that over. And then plug in our numbers. Nothing squared minus 1.2 squared divided by 2 times the distance. And that comes out to 0.38 meters per second squared. Once you've got that, you're away and laughing. You show the total force opposing the motion of the trolley is 16. Well, it's easy. F equals ma. You're going to use that value there, and our mass, which is 42, and 0.38 times by 42, something around the line in the order of 16. So you can do that, put in the numbers, get a value. Once you've got the force opposing it, you could, using the answer to A part 2, even saying that there, yeah, calculate the power required to overcome the total force opposing the motion of the trolley at a speed of 1.2 meters per second. So power is equals force times by velocity. We got our force from there. That's what the force is, the overcoming it, and the velocity is 1.2. So it's just literally that value, which is nearly 16 times by 1.2, and it's going to give you something like 20 odd, I guess. 16 times 1.2, 20, 21 watts, something like that. Here we go. Next one for this bit is 2 marks. If you look down here, you think about it, the mg, the weight, is acting straight down. Therefore, the vast majority of the weight is acting tangentially to the thing. Most of it is just going to be acting this way. A small component is going to be acting down the slope, and that's what we want, that small component there. So of course the one that's adjacent to the angle, that's 2.8 there, and of course that angle there, which is too small for me to draw in, is 2.8. So the one that's adjacent to the angle is the cos, the other one is the sine, and what you're looking for is mg sine theta, basically mg sine theta, where m is the mass of our trolley at 42, g, I think you know g, 9.81, and sine of 2.8. I'll let you work that out and shove that into there. Okay, once you've done that, calculate the resultant force acting along the slope. Well, the resultant force is basically going to be the force acting down the slope minus the friction, and it says here that the constant force that opposes the motion of the trolley is 16 newtons. So we've got mg sine theta going that way, we've got 16 newtons going that way. So we want the resultant force, the FR resultant is going to be that mg sine theta minus 16. Again, you can work that out. Next up, part 2, calculate the acceleration of the trolley. Well, it's going to be the resultant force, it's going to be equal to mass times acceleration. So acceleration is force divided by mass. Whatever this value here comes to, you divide it by the mass, which is 42 kilograms. Again, I'll let you finish it off. Part 4. Calculate the time for the trolley to travel from rest. Okay, u is 0. A distance of 2.5 s, okay, along the length of the slope, and of course we have a, so what we have is we've got u, we've got a, we've got s, and it wants t, so s equals ut plus a half at squared. We can sack off the ut because basically u is 0, so s is a half at squared, therefore multiply by 2 divided by a square root, and we get t equals this. Once you've done that, you can plug in your numbers. Okay, you can plug in the s is 3.5, the a is whatever you get from there, square root it, so times it by 2, square root it, Bob's your uncle, and you get time with it, whichever the time comes to. And then finally, for safety reasons why the slope is not steeper. Well, something sensible. It could get away. The force acting down the slope would be too much. It could pull someone over, etc., etc. So fairly straightforward there.